that. Jeez, oh. I can't believe this. Sorry about that. My mic is actually on mute. And, well, I'll chop and change this. Oh my gosh. So what happened is, I'm going to remember this because I made sure and I was like, everything was working. It was all fine. But my sound settings change in Streamlabs. So it actually didn't select my mic, which is rather annoying. So apologies about that. Once again, for those who don't know, I'm always known to be Sean, your mic is on mute. So this is just another instance of, hey, Sean, you're on mute. Great. Well done, Sean. Great. So let me start off again with this one. Hopefully you can follow the last challenge. So the last challenge was just kind of building it up based off previous, or taking different parts of the web app. So we started off HTML, then went to CSS, JavaScript, and then from the JavaScript, you got different hints about different files on that server. Now, in this case, on this one here, we are doing some sort of WebAssembly, I guess. I'm not too sure what that's going to involve. But when we go and view the web app itself, let's see if I get the web app. So there's this JavaScript that's doing something. We haven't tried it yet, but it's doing something, and it looks like it's obfuscated. Sorry. And shoved it in CyberChef. So CyberChef is a tool by GHCQ. It does a wonderful job. You can do all sorts of things with it. And we try to just make it easier to see what's going on. By and large, it looks solely obfuscated. So we could try to find a deobfuscator that will kind of render the JavaScript. I might try that as well. But the other thing we can do is actually just try it out and see what's happening. So let's just enter a test. Okay. Now, let's also come to Burp Suite itself. And I don't think it's actually sending anything back to the server. Hey, Oxbevin, hopefully it's not my side. Hope you get your network sorted out. So yeah, what I was saying is I don't think it's sending anything to the server. So this means everything has been done within the JavaScript. Now, one thing we can do is bring up developer tools, which is Control-Shift-I. And this will bring up the developer tools, and then we can go into debug, and then we can actually try to see what's going on. It's not as great as I thought. But let's see. Flag. Okay, that's not going to work. So we have to try deobfuscate this thing. And yeah, it's just going to try work out what's going on with this flag. So there's also some inner HTML and all of that. So let's inspect that. Yeah, there's nothing interesting here. The annoying thing is I have solved this before. ABC, and this is not gonna work. And if you got any ideas, let me know. Solve debugger BP on click. Yeah, I'm not a full-on web dev. It's been a while since I've been a web dev. So it does look like they have this WebAssembly, which is interesting because this is something that I am not knowledgeable of at all. So WASM is WebAssembly. It's been around for a bit, and it looks like there's this JISM. So yeah, it's been around for a bit. I don't know a lot about it, and I've not worked with it much, and I've not seen it being used much. Certainly not in the things that I've worked with. But as I said, it's a relatively new technology, and based off the title, some assembly required, it probably has something to do with this. So we're going to have to go off and try see if we can find out about WASM. The annoying thing is, I have done this one before, but it also looks like there's an error loading it. So let's just try load it again. Okay. So it's doing things, which is good. This is all garbled gobbledygook to me. I gotta read up on WASM, which makes me question on how I solved this the last time. Maybe we'll give this one a break and come back to it, because I don't know much about WASM. Yeah. So picoCTF.org is where you want to go to. I think the .NET is all the challenges. So picoCTF.org. I think if you go to play.picoCTF.org, it'll take you to straight to the login page where you can go register. And yeah, some of these are really good, fun. When you know what you're doing. In this case, I don't. So I'm drawing a blank here. I gotta figure out how I solved this the last time. It's just weird. So obviously the JavaScript is causing the WebAssembly somewhere, but as I said, it's probably obfuscated. Now, in terms of JavaScript obfuscation, HackTheBox Academy actually has a really good module on JavaScript. So if you go to HackTheBox Academy, you can sign up free. And there's enough credits to do the JavaScript obfuscation. I found it pretty interesting. And what I want to do is just kind of get some of the pages that are available around JavaScript obfuscation tooling around JavaScript. So there's a bunch of them. Some of them kind of can try to do automatic deobfuscation. So one of them is this JS NAS. So let's try that. I don't know if it's going to work, but let's try it. So there it is there, JS NAS. And what we can do is shove in our JavaScript. I don't know if we need to do anything. Okay, so it's deobfuscating a bit. So we can now actually kind of make sense a bit more of what's going on. So we can actually see some of the web calls or the calls to the WebAssembly, which is interesting. So we've got these flags, we've got copy results. There's still this constant. Yeah. Looks like there's a function that you put in the password. It's kind of weird. There's another site that you can also go off to, which is called JConsole. Just here. I think this is available to everyone. Oh, I've got to check. If not, I'm going to make all these tools available. They're kind of cheat sheets that I'm building out on my Notion. I already have some of them available. So yeah, you can kind of come to this console, plug this in, and it should let you run it. But I yeah, this is all web assembly stuff. It's kind of beyond my knowledge and area of expertise. Yeah, let me come back to this one because I'm gonna draw a blank here and I really have no idea what I'm doing. So let's try another one. One that I'm probably gonna get a bit more luck on. So where are the robots? Well, actually, let's try this one. More cookies. I think I tried to do this one and I got tripped up. So let's try this. See if we can get somewhere on this challenge. So delete everything. Just that there. All right, and clear this. All right, so welcome to my cookie search page. Only the admin can use it. There's a reset, which doesn't seem to do much. Just chords /reset. And is there anything interesting? So there's green, blue, yellow, and red. Call it reset. Those all look like public. JavaScript from CDNs as well as that from Bootstrap, making a Bootstrap app. And then you got some JavaScript down below here. Just looks like an alert box. Right, and anything else here? No, other than calling that. And there's nothing there. Okay, so let's see. I'm just going to clear my cache, call this again so we can actually see what's going on in the cookie. Because based off the name of the challenge, I suspect it has something to do with the cookies. But yeah, we'll see what's happening with that. Where's my burp suite? Okay, so we load that. Okay, it's doing the set cookie. So that's base 64. Which, interestingly, is that base 64? Huh. Let's just copy that. That doesn't look like base 64 because it's got a /, but let's double check. Yeah, it's not base 64. Okay, so we have that. And then when we click on this reset button, what does it do? So does it get with the cookie? And it's just going back to itself. It's got that cookie there. All right. So let's send this to repeater and change things. So that is so weird. Let's just make this like what, -1. This is only the admin can use it. Strong title cannot decide. Categories green, blue, yellow. Yeah. And then this down here. This is strange. I'm just trying to figure out what else there's. Now, I don't know if there's maybe an admin section because only admin can use it, or You gotta break the cookie. Let's just try admin. No, it's not it. Login. No. Okay, so we're gonna try and break the cookie. And the admin can use it. More cookies. And what is the cookie being used? I guess it's trying to break this and make this an admin token or cookie. So let's go to Cyber Chef. Oh. Come on, how did I not copy? Oh, so used to Mac. It's base 64. Now, that's interesting. No, wait. Not to from. Okay, so it always ends in this /CL. It looks like a plus. I wonder if there's some type of like encryption or something. Just out of interest. No, it's not there. I don't think there'll be any of these. Alright. And there's no other information. I forgot. Okay, so the cookies can be client sites. So I decided to encrypt them. Okay, so they are encrypted. So there is some tools that you can use for encryption. I forgot the one tool, what it's called. But yeah, let me get it quickly. Yeah, no, I forgot. It's a French site that has a bunch of encryption stuff. But given that this is a beginner-ish type thing, let's see if it's maybe one of the kind of known encryption algorithms. So what we could do is it going to be like something like ROT13? I think it will be, because that's rotating the characters. So the way ROT13 or rotate 13 means is it rotates the each letter in the alphabet 13 characters, and then like wraps around. So A becomes whatever, A plus 13 characters down the line. But that's not going to be the case here. And it won't be Caesar cipher, because Caesar cipher is a form of a rotation cipher. Why is that doing that? It's weird. Yeah, I don't think it's going to be a Caesar cipher either. Yeah, so it's going to be trying to figure out the encryption used for this. Could it be... I think it's going to be Des. Oh my gosh, this is horrible. Des. We still need a key though. That's the problem. So I don't think it's a symmetric cipher. So symmetric cipher is a cipher suite that takes the same key to encrypt, and then takes the same key to encrypt, and then the same key to decrypt it. So in this case, trying to figure out what cipher this could be. If anyone has any ideas, just drop them in the chat. But I am drawing a blank on the encryption algorithm used. I bet you now it's going to be something simple. A64. Oh my gosh. It's a bit of a bug of the year, yeah. From base 64. So it always has this on the end. So maybe if you just do a Google cipher, well, it appears to always have that on the end. Let's see if. Oh, okay. Actually, I had that. So there's this tool that will automatically try to determine what cipher suite it is. So let's try put it in there and see what we get. Okay. Base 64. Okay. Well, it's not a base 64 because we have that already. So decode that, it's just going to be gobbledygook. Let's just take this. Yeah. Was not gonna be that easy, was it? I don't know if there's a way that we can. Does this have any hints? We might need to use a hint. Because yeah, the base 64 is wrapping it. Maybe if we try the over base 64, maybe it does like decoding behind the scenes. No, it's definitely not base 64 is coding it. Nothing interesting there. Okay. Let's look at the hints. I'm gonna have to use a hint. Oh my gosh. Homomorphic ciphers. I don't know much about homomorphic ciphers. Let's try decrypt. This is my day job. Spend time Googling things. Okay. So actually this was the site that I was looking for. This is a really good site for encryption things. It has just loads and loads and loads. If you come here, I think it will give us options. Oh, we went English. Unfortunately, I can't speak French. There was another part of it. It is the site where you can decrypt and you can specify algorithms and all that kind of stuff. I think it's yes, somewhere. I can find it. Was it this? Okay, let's actually see if it's gonna find this. I'll be impressed if it finds this. Analyze. Okay. So put that in. Let's try run that. Without it. Okay, so that's definitely not the flag that we want. Okay, so SOAP has something here. The entropy, so SOAP's going entropy is probably encoded. So I'm just trying to read your message. SOAP. Yeah, MK Asta. It is encrypted. It's using this homomorphic one. Just trying to figure this out. So that's encoder, decoder. I try that. No, that's not gonna work. Let's try one more. Search endpoint is only input. I mean, wait. Here's the flag name. This one's not locked. Which I guess is because this is probably quite tricky. Homomorphic, homophonic. Wait, that would help. Are they actually the same thing? Homomorphic, homophonic. I guess so. I don't know anything about this encryption algorithm. I've never really come across it. So this is the other thing about CDFs. You're going to come across things that you've never, ever used or seen before in your life, which is sometimes it's a good thing. But you just got to be careful because sometimes, like, how useful is it? Like, I don't think this type of algorithm is actually used that much. I could be wrong, but I've certainly not seen much of it in use in anywhere. So let's just see if we can play around with that a bit. There's no. Okay. Yeah, I might need to do a bit more digging up and reading on this. Again, that's why I haven't solved this before. Yeah, maths. That's where I start falling apart. I used to be alright at it, and now I've just forgotten everything. So we could probably try, I don't know, script something or something like that. But yeah, we're probably not going to get very far on this. And I guess it's also trying to work these out. I think. I don't know. Anyway, let's not delve too much on that because that's is going to take a bit of time. Just see, that's where are the robots? All right, let's do a new one. Where are the robots? And see how this one goes. And just to be clear, I am by no means any good at CTFs. This is why I want to do more of these things. I suck at CTFs. So I want to try to do more and get better at them. You can all see me fail miserably. Which is my normal CTF type pace. Fail. Alright, so where are the robots? Welcome screen. Anything interesting in the source code? That's just Google Fonts. Anything in style sheets? Yeah, it doesn't look anything interesting there. So we have, I don't know. That's not going to be idle, is it? And there's nothing else. Jeez. I actually want to try this here because this might make it cleaner. I think that's just an ID to the challenge itself rather than a thing for idle. Yeah. Let's see if there's anything there. All right, so robots. Okay, nothing there. Now, it could be playing on robots.txt, like I mentioned earlier. So there's certainly no sort of, I don't know why my screen's going all weird, cookies or anything like that in the response. So let's have a look and see if there's any robots.txt. So robots.txt. Okay, so yes, we got somewhere. So this is what I was meaning earlier. You can start formulating information about the site. So now we've got a page. Well, okay, that was a bit disappointing. Yeah, I mean, this is sometimes CTFs. I get it. Judging these things are hard. So sometimes you'll find like an easy challenge that's just like, wow. And then you find sometimes a harder challenge that's just really, really, really easy. So in this case, this one was pretty easy. Certainly easier than the like more cookies and WebAssembly one. So let's go into the next one. And I'm gonna like kind of create a macro or something that can do all this. Just click a button and it just clears everything. Let's go there. All right, so we've got this factory login, a login page with a home button, a sign up button, and a sign in. So if you just enter in gobbledygook, see what happens. Okay, so we're logged in with some random things. I guess you get to log in as an actual valid user and you get the flags. So let's see what went on behind the scenes. So looking at the page itself, that's I thought I cleared the cache. Let's just get rid of this. Delete select items. Maybe it is there. All right. There is nothing there. It's all kind of third party. So we log in. Okay, so we can see these cookies. All right. So there's a flag with the admin. So don't say it's that easy. So what if we change this to true? Okay. Yeah. All right. Yeah. That was it. So we just changed the flag admin to true, and voila. There's a flag there. All right. So next one, don't use client side. Cache and get rid of the stuff here. All right, let's go. So secure login portal. Enter invalid credentials. And anything interesting yet? Oh. Okay. So it's doing a bunch of things there. Okay, so it's this. Okay, I'm trying to work out the right way to solve this and the wrong way. I think this is the way to solve it. Just piecing these together, because as the name suggests, the challenge name, don't use client side, which exactly what this is. is that although it is mixing things up, so we'll have to just reverse engineer it, but we can go off and try that. Yeah, CTFs are certainly a great opportunity. I enjoy doing them. It sometimes challenges you, it pushes you, it makes you learn new things. Sometimes it can be really daunting. So I think the point with CTFs is know where your limits are. Don't push yourself too hard because you're just going to get frustrated and just give up completely. I mean, CTFs in general. Like the previous challenges, when you're not getting anywhere, it's pointless carrying on and on and on. Just move on and then come back to it with a fresh set of R's or get someone else to have inputs, something like that. Also, thing I've learned about CTFs along the way, and again, this is why I don't think they're always really relevant to real world. And don't get me wrong, they are really important. Is that they have their quirks. So there's kind of ways that people do things around CTF. So you got to know what tools that people use, the kind of thought process that goes into some of these challenges and that. So yeah. And yeah, from Sulp, definitely join up with others. It's a really good way to do CTF, so you share knowledge, not just knowledge, but different ways of thinking about things. So, having said that, let's go off and try to figure this out. So we know picoCTF is kind of it there. So let's try to figure out what this is doing. So this verify script, assume, is getting called when you do the submit. Yeah, so on click will mean it'll call this JavaScript. There's this check pass, which is getting the value from this input field, which is called pass, and it's splitting it. The split is 4, so I don't know what that's doing. Okay, so this, and this is probably where we can come into the browser and use the debug tool. So this is doing a substring split, so it's taking the first 4 characters and checking if it's pico. So what we can do is go into our debugger, and we should be able to set debug points here. So if I enter in, like, say, tests, you can now see that if we step over it, so step over means just go to the next point. So if we check pass, we can see that it's test. That's what I entered. That's going to be 4. So if we step over it, now check pass substring 0 to 4 is going to be test, and that's not going to equal picoCTF. So therefore, it's going to go out into the else and go incorrect password. And there we go. We just click pay to move along. So this is probably where we're going to need our trusty thing. Yeah, and we go. So definitely the first one that we want is pico. So we want it to match this, all right? So if we do that and enter in gobbledygook after that, so there's pico. So the first 4 characters are pico, so it should pass that first if statement and go into the next. Now it's taking what's split times, so 4 times 16. Oh, sorry, 4 times 6 is 24, and then 4 to 28. So the 28 characters should be that. So what we're going to do is just basically fill in. So it's kind of interesting. It's pretty cool. So that's 1. So we're going to make sure this is what, 28. 26, right? To 28. So if we now step over this, and I'm now just going to move the breakpoint because we progress in there, so we don't need to go into that each time. So we'll get there. So yeah, we passed that. So the next one is split, which is 4 to 8 is CTF. I don't think we need to do this each time. So we'll just step through 1, 2, 3, 4. Split times 4 is 16 to 20 is that. 1, 2, 3, 4. I think I got this wrong. 29. No, 26. Okay, cool. What was that I put in? T underscore. This one, 4 times 3 is 12 to 16. 1, 2, 3, 4. Uh, 20 to 24. So it'll be. Wait, what? 20. No, wait. Let's just make sure this is working up to a point here. I don't want to do all this. Get myself confused. Oh, why is it not copying it? Copy. Let's verify that. Like, what? Okay. Getting there. Okay, so we're not getting there. Splits. Why is that? That's 4. So weird. Where's that? It should work. That's. Oh wait, what? Oh. Maybe it's. No, it can't be that. That's split, which is 4. Yeah, this is strange because this, what this is saying is 0 to 4 is pico, and then 4 to split is CTF, but that can't be possible because that should be split plus 1. Just trying to work. That's why it's not getting in this bit here. Wait, what am I doing here? Okay, so that goes there. So we're passing the first one. Oh, okay, so we're failing on this end bit here. Oh, that's. Thought I messed something up. So that's what, 4, it's 24 to 28. 8. I'm getting myself all mixed up. 24 to 28. Now this should be a bit better. Apologies about that. Get myself all confused. No, I'm still getting that wrong. Jeez, why can't I do math? What have I did? 4 times 6 is 20, 24 to 28. Ah, I think I need one more. I think it's starting index 1, not 0. Like when you're doing this split things. Ah, yeah, because here it's starting at 1, not 0. I'm messing my mind up. And this is starting at 0. That's why there's a disconnect. Cool. So now we can start filling in the rest. So that, yeah, we've got that one. That one's working, should be. So if you step over, yeah. So that is what? 4 times 4 is 16. So in this case, it'll be 17. That's where I was going wrong. 1, 2, 3, 4. 0 indexing. It's always going to catch you out. 12 to 16. So 13. 2, 3, 4. And that is 20 to 24. So yeah, it's 21, I think. Yep. There. That's 8, so I guess it's that there. And then the end bit. So if we got this right, I'm just going to take the breakpoint off. So breakpoint, you just click to set the breakpoint, click to take it away. Resume means you'll hit the breakpoint and then you can click on resume and it'll just carry on. And then step over is just kind of iterate through. This is just really quick overview of a debugger. And then you can also step into, which will actually go into the method. So if you had like another function here, you could actually see the code. Because this is within the browser engine, I actually don't know what actually goes. Yeah, I don't think you can go into these types of things because these are built in. But if you had like another function there, you could then step through that, and it's walking through the code itself. So we don't have a breakpoint anymore, and you can also have this pause on exception. So what I'll do is if there's any error in an exception, I'll pause and you can step through it. If we've got everything right, we've got password verified, and that's that challenge solved. So if we go, yeah, we can solve that one. There we go. Cool. So I just got to remember where I ended here. So do not use client sides. What we can do, since I was so bad at that homomorphic one, let's do this one. Simple rotate 13. Now, this is a old cipher suite. By old, I mean it's going back to kind of Roman times, and you'll see now why I say that. So don't know why this is doing this. The way that this works is, as the name suggests, it rotates. So as I said earlier, A becomes, I don't know what's A plus 20, A plus 13. I don't know what that is. But like, and then B becomes B plus 13 and so forth. So if you think of like it being on a cylinder, you just kind of rotate it. So in this case, rot 13 means rotate 13 times. So C becomes P, V becomes I because it wraps around. So in this case, A becomes N. So that's, yeah. If you think A starts at 1 and N is like, what, 14 in terms of index in the alphabet. Now, obviously, you have uppercase letters as well. So this will be ASCII values. So you could actually work it out using the ASCII table and just add in 13 to it. But yeah, so in this case, there's the solution there. And that one was quite easy. Now, as I said, it is from Roman times. So you actually have the Caesar cipher, which should be here, I think. Is it? Did they actually call it Caesar? Yeah, so you got the Caesar box cipher. No, that's not what I'm looking for. But yeah, there's also the Caesar cipher, which is built upon that. So as the name suggests, it's from Caesar itself, and it builds upon the rotation cipher. So that's what they used in the Roman times. So that's that one. Mind your P's and Q's. This one is in terms of RSA. Oh, okay, sorry. Rotate 13 is Caesar cipher. Yeah, sorry. I get myself, thanks, Sol. I get myself mixed up with all these cipher suites. So yeah, this one here is a bit of a pain to solve. Now, there is the best way to do this is one of two ways. You can use something like OpenSSL, or you can use a library or online tool. So in this case, let's open this up. What's this? So you have these. Now, RSA is a public key cipher. It's known as asymmetric because you don't use the same key to encrypt and decrypt. Where in terms of, say, something like we just saw a Caesar cipher, the key was the number of iterations or turns. So in that case, ROT 13, the key is 13. And that's a symmetric. So you use the same key to encrypt and then the same key to decrypt. In terms of asymmetric, it's a different key. Now, the reason why you can have this notion of a public key, which is again what most asymmetric ciphers are, the public key in encryption is you can have this key that you can give to anyone, you can make it public and still have the integrity of the cipher intact, and that's using mathematics primes. So where you add two large primes together to form this value, and it's computationally infeasible to work out what those two large primes are. So in this case, n is that number that's computed together, and you have a p and a q, which are the two primes, and that's why it's so important to never let either one of those out, because using basic maths, if you have one of them and you have n, which is public, you can then work out q, which means you can break that private key. And then you have other things like c and exponent. Now, what we can do is online RSA key calculator. There should be I think it was our good friends at decode.fr that had the tool that what we needed. So we have some values here. We have n. We have exponents. And we have the cipher message. All right. So if you decrypt that, and there's our picoCTF. So there's a flag. And this works because we... Trying to remember why this works. So yeah, it could work out P and Q. And now the reason why that's probably the case is because this isn't large enough. I don't remember. But yeah, the basic premise of public key encryption is because you have two prime numbers, P and Q, and they're large. They have to be large. And this is why calculating a private key for RSA and that is computationally expensive, because it has to try to find those two prime numbers that are sufficiently large enough to then multiply together and get N. And that way you're not going to get what do you call it, the prime numbers. Like in this case, because this is weak, I think it worked out the prime numbers, and then away you go. So yeah, that's that challenge. So now I realize we've been at this for a bit and I need to go off and sort things out. But yeah, hopefully this has been helpful. I enjoyed it tonight. Apologies about the mic at the beginning. As normal, I'm on mute. Always on mute. But yeah. And thanks for watching. Thanks for attending. I'll try run another one next week. Might read up on some of the other things. I'll see if I've got time. But yeah, thanks for watching, and hopefully catch you all next week. Have a good one. Bye.
Swear I won't forget this, why do I regret this? In my mind reckless, thoughts are feeling endless. Sitting up, I'm breathless, anxiety's infectious. I feel so defenseless, betrayed and embarrassed. I hate being open, I hate being broken. I feel like an ocean filled up with emotion. Anger ain't a potion, rub it on like lotion. I can feel it soaking, reopen, the scars have awoken. I can't move on till I let go. I feel so lost, never at home. Need to be strong, every breath hold. Cause I can't move on till I let go. I can't move on till I let go. I feel so lost, never at home. Need to be strong, every breath hold.